Okay, everyone joined again. Please tell everyone to join again. I think their license has been finished, only 40 minutes available. So it's okay, no problem. We can join in between 40 minutes. Then anyone comes? Okay. Tell everyone to join again. Okay, 6 people. Start again. Okay, as I said, the errors means error is equal to true value minus estimated value. Okay. So, so let's see some of the type of errors. I think in your notes, I have put something here and there. Please change it. Okay. Next one after this one, you have to put the types of error. Then only the next section comes to use. So that is all notes. I just edited. Okay. So when you're writing, you just write this. Okay. Human joint. Okay. The errors in solving scientific mathematical problem which involve a computational procedure roughly can put it in the following sources. Okay. So anyone joining? 89 only there. So tell them to join. Okay, so types of errors. So let's see some of the types of error which we encounter in some scientific mathematical problems, experiments, and computational procedure. Okay. So first one we say limitation to the measurement. Why this like these errors are coming? Okay. So this is because the errors. Okay, so why these errors are coming? Because of some limitation of the measurements. Okay, limitation of measurements. So what it means? There are three types of limitation of measurements we can see. Okay, let's see one by one. For example, in the first so from next lecture, I will read everyone to join. There's a problem with that. Okay. So first one is instrumental limitations. So instrumental limitation means any measuring device can only be used to measure to with a certain degree of fineness. So our measurements are no better than the instrument we use to make them. Okay, it means, for example, if I have a weighing, any weighing like this, weighing mass, okay, in the chemistry lab or physics and everything. So if I have this machine is only taken for significant digits. Okay, or three significant digits. So if I have 2.562, okay, it is taking us 2.56, let's say. Okay, so even if I take 2.66, I mean 29 something, it's also still 2.6. So this and this have different values, but this machine only taking limited degrees. So therefore, the errors also may comes in this reason. So that's what it says. Any measuring device can only be used to measure to a certain degree of fineness. Then our measurement are no better than the instrument. So instrument, what the instrument take is the value. Okay, so it will be having some errors. So next one, this is one of the limitation of measurements type of things. Second one, systematic errors and blunders. Okay, systematic errors and blunders. Blunders means blunders we call maybe the reasons of careless mistakes. Okay, and systematic mistakes. So these are caused by mistake which does not change during the measurements. Okay, so because of the careless, if you set the machine to three significant or like that, or if you measure something wrong, okay, if you put it in a different measurement, so there are a possibility it makes errors. Okay, for example, in a platform balance, okay, that's what I have grown earlier also. Okay, like this, let's say there's a let's say this is our weighing machine. Okay, the platform balance we used to weigh something was not correctly set to zero. Even in our weight machines, if you don't put, the let's say the weight machine, it has some problems to come to the zero. For the zero, if it is in the 10th value, okay, so our weight will be show something weight plus 10 grams or anything. Okay, so that will be a mistake because if you weigh 1,500, it will be 10. Okay, and each time we weigh in, it will be making mistake and mistake. Then at last, it will be give big mistakes, big errors in our machines. Okay, so that's what we say. It was not correctly set to zero with no weight on the fan. Only subsequent measurement of mass will be too large. Okay, so if you don't put correctly, it is also uncommon. This is a careless mistake. Okay. Likewise, we can discuss some as well. Systematic means the systematic errors do not enter into the uncertainty. They are either identified or eliminated or looped in the background. Okay, loop means hidden. Okay, hidden, remain hidden. If we don't correct ourselves, it will be there forever. Okay, so systematic means errors is a thing we have to consider when we doing the measurements and all those. So loop means remain hidden. Okay. So systemic errors do not enter into the uncertainty. They are either identified or eliminated or loop in the background, producing a shift from the true value. So it will give you some error. That's what it says. Okay. Okay, next one. So likewise, we are seeing the third one. Okay, first one is the instrumental limitations. That is also causing some limitation to measurement errors. And next one, systematic errors and blunders also making careless mistakes. Systematic errors also making. Next one, third one, we call as a random mistake. Okay. under the random error, these arise from unnoticed variation in measurement techniques. Okay, and tiny changes in the experimental environment. For example, if you are doing one group doing the experiment in a good weather, let's say the temperature is equal to 32 degrees. And other group doing the same experiment is equal to 35 degrees. Okay, so if they get both, uh, the experiment, if they copy or anything, but if this environmental changes, there should be a difference between them, isn't it? So that kind of errors we call as a random errors. Okay, unnoticed variation in measurement techniques. So techniques also different. Some are doing, uh, like, I mean, for example, different techniques also cause some errors. Okay, that's what it says. A random variation affect precision. Okay, accuracy. It may affect the accuracy. So truly random effects average out if the results of a large number of trials are compared. So if these are very powerful when we are doing a large number of errors combined, we will have a very large number of errors. So that's very safe. So you can read out and understand what it is saying. Okay, likewise, the limitation to the measurements, one kind of types of errors. Okay, so see the numbers also, how I have numbered here. Please change it in your module. Okay, I didn't change in your module. So this is, you better very focus on my notes and the module. Okay, module has been created earlier. Some I have did, some from the other things. So this is my note. So if I'm making any changes, you just note it down in your notes as well. Okay. In next lectures, I will try my best to give you my same notes. Okay. So likewise, limitation to measurements. Let's see the next part. Okay. Next part of types of errors is coming by the uncertainty of measurements. Okay. So let's see what it means. What is the meaning of uncertainty? Okay. So errors are quantified by associating an uncertainty with each measurement. For example, let's see what it means, the uncertainty. For example, one person taking the best estimate of length is equal to 2.5. Okay. They take the length, L is equal to 2.59 is the actual length, let's say. Okay, best estimate. But the uncertainty, one person taking 2.57. Okay, when because of his measurement problem and putting here and there, there's a mistakes coming. He taking 2.57, and one more person they take 2.61. Okay, this is larger one, this is smaller one than this. Okay, there are two kind of uncertainty measurement can be found. So these L can be expressed with uncertainty. These also can be given in two different ways. Let's see what it is. Okay. First one we called as an absolute uncertainty. Okay. So absolute uncertainty means, so expressed in the unit of measured quantity, same quantity. Okay. For example, L is equal to, let's I think you may find this one in the practical times. They say 2.59. There may be acceptable of 0.02 centimeter errors also. For example, even in our maths, if you see the marking scheme, some people if they 2.9 will be the correct answer. But even though they give the marks for 0.02 also. Okay, this kind of things we call as an uncertainty, but it calls uncertainty of absolute uncertainty. Okay, giving in this way in the same measured quantity. Okay, next one. In the same way, there is another way we can talk about the uncertainties. Percentage uncertainty. Some can be written in the same measurement value of 2.59. So one is absolute one, 2.59 plus 2 minus 0.02, same centimeter or meter or gram or anything. Anything in the same, they adding plus or minus something. Okay, but other one is percentage. They are giving in the percentage errors. For example, express as a percentage independent of the unit. For example, so if you are saying the 0.02 in 2.59, what is the percentage? So if you calculate this one, it will be approximately 0.077 something, right? So you can calculate that. So they say it is absolute approximately 1%. Okay. So then they are giving this error measurement. L can be 2.59 centimeter with plus or minus 1%. Okay, like this. The same 0.02, okay, the same 0.02 can be written in the form of 1%, like this calculation. Okay. So this was the two way of uncertainty representation. So next one, third one. Okay, first one is, so what is the first one? First one is a limitation to measurement. Second one is the uncertainty of measurement. Uncertainty. Okay, the third one is the error measurement. Let's see what it is. So if it is an error measurement, there are some things we have to consider. Okay. So let's take x star. X star is the estimated value of the number x. This is our true value, and this is our estimated value. Okay. So if you have, so what is the absolute error from the true value to the estimated value? So I told you some may be take for the 2.99 is 59 is the exact one. Some may take 2.57. Some may take 2.61. This is a less than one, less one. This is a above one. Okay. So larger one can be this. So there's the mistakes can be plus or minus. Okay, if it is this one minus this one, it will be positive. If it is this one minus this one, will be negative. But we need the value only, not need the plus or minus these things. Okay, so that's why they use the absolute, this modulus. Okay, so you may know the absolute value means what? Minus 5 means 5. Even the plus 5 also 5. Okay, that's the idea of absolute. Okay, everything will come as a positive. So we need the value only, not the plus or minus. The error can be plus or minus. Okay, so that's why they use the absolute notation. So the absolute error is in X3 defined as the delta. They use the delta notation. Delta notation is equal to modulus of true value minus estimated value. This is called as the absolute error. Okay, for the error machine. Similarly, if we say, we may have these words in the step or in the all over, right? Relative error. Relative error means they use the delta of from the exact value, how much the absolute value. Okay, so this is a formula for the relative error. Next one, we give in the percentage. So percentage of this relative error. Okay, delta percentage of 100 times of 20. So please note down all these. This is something we can get some questions. Okay, let's do one example on it. Can you try this example? Let's say this is our, and give me the answer in the chat. Okay. Let's say our true values is 2.7632. Our estimated values equal to 2.76. For the 32, they have taken as 4. So how the error will be changed? So that's the idea. Okay. Can you calculate and give the answer in the chat box? Please everyone answer me. That everyone join? Say anyone waiting? 85 people are there. So next time I will let you without waiting. Okay. This time I will check that. Have 10 minutes. Can you try that one and give me the answers? So we can finish up with that. I'll show you the answer. You just answer me. And one more thing, I think, so today you had the MTM of Orion differential equation for 2 hours. So you don't have to more than one minute. Answer me anyone. If possible, I will take because our time for this course is fixed for Thursday 1 to 3. Okay. So today sir has some duty that I have taken this time, but we have fixed our time will be Thursday 1 to 3. Okay. So if possible, shall I take the Thursday also tomorrow? So because next week we'll have a holiday, no? Thursday and Friday we will have a holiday. So it's better we finish that week also. What do you think? Give you decide and tell me today itself in the WhatsApp group, okay? Anyway, I would like to have it tomorrow also. 1 to 3 or not like 2 hours. I will take something like that. Like today, not much. Just I think you have morning lectures. I will try to have 1, 2 something. Okay, where's the answers? Only 1 or 2 only answers. Try your answers for everything, okay? Try the absolute error, try the relative error, try the percentage error, and answer me comma comma. You put a comma and write me in a one line. Don't write 3 messages. Just type in 1 line and send me. I'm waiting for your answers. So just use this not formulas. So absolute error, you can use this one. For the relative error, you can use this one. And percentage times this one, okay, 100 times. So simple. 5 answers, 5, 6, 7 answers. There's the others. Everyone make use that form, okay? Don't just waste your things. You have to be careful in your lectures. Only you can get the good marks. So 88%. Is anyone waiting? So we can finish up this. Give your answers. At least try yourself. Okay. Okay, that's it. So let's see the answers. So x equal to 2.7632. This it seems, see, these two are seems a little bit of answer, even the third digit, isn't it? After the decimal, third digits only changing. But see how much it makes in the entire procedures. Okay, so that's the ideas of error measurements. So if you see absolute error, we have delta is equal to modulus. So please follow these steps of answering. Okay, don't just give digits. Just write nicely. Now you can copy even. Okay. So nicely write the answers. Even in the exam also, we are expecting nice answer like this. So the absolute error is in x star will be delta is equal to x minus bar. So if you put inside, there's a negative coming, but with the absolute, it will be vanished. Similarly, relative error will be this divided by true value. It will be approximately 0.0003. Okay, and the percentage error will be times 100 will be the zero count. This will 0.0. Okay, so that's all about. So we can continue each other. If possible, I will take tomorrow. Okay, like 1 to 3, possibly. Okay, so we can somewhat we can finish up our chapter 1. So if you have any query, you can let me know personally in the WhatsApp and everything. Okay, so hope we can meet up tomorrow with new topics. Okay, so we are not yet finished the error section. Of the error section, we will continue the other solution of one-dimensional this one. Of course, in the chapter, so we are in the number system and errors. If we finish this one, we can continue the solution of the equation in one variable. That is very interesting part. Okay, so hope you all have a good evening. Okay, goodbye. So we can finish up. Bye.